Okay, now that we have a new schematic open, let's add a schematic frame. Ensure all libraries is selected from the drop-down menu here. Scroll down to frame underscore A underscore L. Or you can type in frame underscore A. And then here's underscore L. So I'm looking for this right here. And to place it on the schematic, you're going to double click it. And then you're going to want to line it up right at this origin right here. So this is our reference origin. So the schematic will be placed there, and it lets you keep placing these. If you have multiple components to place, it's going to keep that engaged. To not place a second schematic page or frame, just hit escape, and that gets you out of that placement menu. It is very important that you keep your version control orderly. Just like software management, every time you make a change on the schematic or PCB, you should increment the version number and create a README file on what changes were made. Let's save the file as blink LEDs. File, save. Notice the scroll wheel controls the zoom function. And if you're in Fusion, you're definitely going to want to use your scroll wheel. By default, it is reversed from most other software zoom functions. Let's fix that real quick. Click on your profile at the top right corner and select Preferences. In General, scroll down and check Reverse Zoom Direction. You can see mine's already checked. Once you check this, click OK, and then you should be able to scroll down to zoom out and scroll up to zoom in. Before we start building the schematic, let's talk about libraries. Every part you want to use needs to have a library in Fusion. Many common parts are already included. Let's add 3 libraries to make our component selection bigger. First, let's download some library files. I'm going to navigate to UTA EE Lab homepage to find the link to our GitHub page. Scroll down and click on Fusion PCB. Click the green button and download the zip file. We're going to open the file and we're going to unzip it, extract all, and under the libraries folder, these are the 3 libraries that we're going to add. So just remember they're in our downloads or your downloads, and we'll come back to that in just 1 second. Back in the Fusion schematic, click the Library tab, then select Open Library Manager. Click on Import Libraries and Import from Local Disk. Here we're going to find the file we just had, and we're going to select the MFR 25FB F25-1K.library. Click Open. This one library file is for a common resistor we keep in stock at the lab. Some of the other resistors students have used before have holes too small for the leads of the resistor to fit through. So use this library for all of your through-hole resistors. Let's do the same thing for Adafruit library. File, import from local disk, Adafruit library master, Adafruit library, open. When adding the SparkFun libraries, you'll need to import all the .lbr files. File, import local disk. Let's go back to SparkFun. Now there's a whole bunch of them. You can select one and hit Control A. That selects them all. And hit open. Let's look to see if these libraries are in use. Search for MFR. Let's filter that here. MFR dash. And you can see here's the library we just added. And you can see it is in use. And we can check the other libraries as well. And I have several of these libraries already installed, but they are all in use. Okay, go ahead and close the library manager. So we are going to make a simple 555 timer circuit that will blink 2 LEDs. This is just like the Solder 3 workshop, but we're going to use through-hole components. Type 555 into the component search area. I see one here by Tinkercad right here that has a schematic, a footprint, and a 3D model. I'll use that one so we can have a 3D rendering of our PCB later. Double click it and place it around here. And about right here. And hit escape to stop placing. We only need one of them. We're going to need 4 resistors for this circuit. So select Adafruit as a library to search from. I'm going to actually use a different resistor. We are going to need 4 resistors for this circuit. So select Adafruit as a library to search from and search for R-US. Okay, so here is, if you click on it, you'll see the details, and you'll see down here that the schematic symbol is a general resistor, but the name and value of this footprint, this is obviously a surface mount device. You do not want to use this part. You want to change the variant. This is a very, very small surface mount resistor. You're going to change that variant to the 0207-10 right here. And that changes it to a through-hole resistor, and it is basically 10 millimeters of spacing between the holes. Double click to select that part. And I'm going to zoom in here. Right click to rotate the resistor and place them like this. R1, R2, R3, and R4. And that is all the resistors we need. Hit escape. In the center of R1, right click the crosshair and select value. Right in the center, click value. Type 1K. If you want to add the ohm symbol, you can hold down the Alt key and type 234. And that adds an ohms symbol. Make R2 100,000 ohms. Right click, value, 100K, Alt 234. R3 and R4, make those both 100 ohms. We need to add two capacitors also. First, let's find the electrolytic cap. Select Adafruit as a library to search from, and search for C polarized. And if I click on that, and if I look at the, here's the schematic symbol, here's the footprint, which is obviously another surface mount device. We do not want that in the variant column. We're going to select the E2-5. There it is. If you scroll down in the details frame, you can see the electrolytic capacitor has a diameter of 5 millimeters and the lead spacing of 2.032 millimeters. Measuring the dimensions of our capacitor we plan to use on our PCB, we see that the diameter and the lead spacing matches perfectly. Place this component around here and press the escape key. Right-click the component and select value. Enter 2.2 microfarad for the value. The other capacitor is a 10 nanofarad or 0.01 microfarad capacitor. We'll download the library from Mouser. We will be using the K103 K10 X7 RH5 TH5 capacitor. You can see the ECAD model section. This part has a PCB symbol, footprint, and 3D model you can download. Click on the ECAD model and a pop-up from Schematics should come up. If this is your first time downloading a library file from Mouser, click on Create a Free Account and fill out the form. You will need to confirm your account with your email, but you can download your first part before you confirm your email. Simply click Download CAD Models. Extract the downloaded zip file. We're going to open the Library Manager again. Library Manager. And we're going to click here, Import from Local Disk. Go to my downloads. Go to the same file, import it. Now you can search for that exact part number in the search. So let's close the Library Manager and click back on Design. Let's go back to All Libraries, and we're going to search for that K103, and here it is. So double click on that, place it around, I'm going to do a right click and place it right around here. We only need one. I'm going to hit escape. We're going to do a right click, hit value. It says has no defined value. Do you want to change it? Yes, we do. It has this part number for the value, but we're going to change that to 0.01 microfarad, which is a lot more readable. And the reference designator has incremented to C2. Perfect. Okay, we need some kind of power to power our circuit here. And what I've decided to do is we're going to actually put a USB-C connector to supply power to our circuit. And I found something on Adafruit that is literally just a USB-C power-only connector. The item number is 4907. And there is a link to the library in the description and on our GitHub page. So we're going to add the USB 4125 to the library and place it instead of a full USB-C connector. So I'm going to go to Library, open Library Manager, import from local disk, and I'm going to go back to Downloads, Libraries. This is what we downloaded earlier, and here is our USB 4125. This is a power only. There's no data connections. It does make it a lot easier to solder. Search for USB 4125, double click, and we're going to place it right. I'm actually going to turn this around, and I'm going to place it right here. Press escape, and you'll notice on the footprint it has a lot less pins than a normal USB-C data. So the data pins are actually not needed at all. But if you look at the data sheet, we will have to place two small SMD resistors to make the USB-C power supply work. So search for R-US underscore chip dash 0805 and select the one from Tutorial Fusion. So this is Tutorial Fusion. It actually has a 3D model, and we are going to use the 0805 surface mount resistors. Double click on this, place two right around here. I'm going to right click to change the orientation, and let's put one here and one here. Press escape, and we're going to set their values to 5.1K. So click in the right click in the middle, value 5.1K, and this one value 5.1K. Okay, and we'll come back to those in just a little bit. We also need a couple standard 5mm LEDs. Let's search for LED 5mm, and I'm going to use one from Adafruit and place two of them around here. And let's put one above this first one and one in between them. And those are the two LEDs that we're going to need. The last part is we need a simple push button. I'm going to download the library for a 95C06A2T momentary single pole single throw switch from Mouser and use it. Okay, this is a common switch that we keep in stock. I'm going to go ahead and get the footprint here. I'm going to download the CAD model. I'm going to open the folder. I'm going to unzip it. Go back to Library, Library Manager. There it is right there. Go to Eagle and import it. Now you should be able to search for the 95C06 and double click. You're going to place it around here. Hit escape. And now we have our momentary switch placed. Now we need to place three ground symbols on the schematic. Search for GND-bar. And I'm going to use the one from Eagle Power Symbols. Place them roughly in these locations. We're going to need one here here. We're going to need one here. We're going to need a ground over here. We're going to need a ground over here. And I believe that is all the grounds that we need. Okay, press escape. Now we're going to need a power source to connect to our different locations. Go ahead and just type in VCC and find the one from the Eagle Supply 1. Right here. Double click that, and we need to place one over here, one here, one here. Do a right click 3 times, place one here. Do a right click 2 more times. We're going to place one here. And that should be all the VCCs that we need. Press escape. Now let's create 2 major blocks for our schematic. Click on the Documents tab and select the USB-C, the VCC, ground and push button like this whole area. Select them all and right click on the USB-C and select New Group. And we're going to name that Power. And basically all that does is it sections off part of the schematic specifically for our power parts. And then now let's select all of our other components and group it as timer circuit. So take everything else, do a right click and new group, and we're going to call that timer circuit. And that just helps break up the functions of the different components. We are now ready to connect all the components and power. Go back to the Design tab and select Net, which is right here. So we're going to connect the ground of the USB to the ground symbol. So we come over here, we'll see this is our ground. Oops, I do need another ground. So what I'll do is I'm going to hit escape. I'm going to hit this ground, hit copy, and I'm just going to paste it right over here. Then I can go back to my net. Now I can click on this part, and now the ground of the USB-C power is connected to the ground plane on the PCB. Next, we are going to connect the V bus of the USB-C to T2 of the push button. So this is V bus, and this is going to need to go to T2. I'm going to bring it over here. We can clean all this up later. So that's connected now. So the power is going to go to terminal 2 of the push button. If you right click the wire and go to properties, you can see that it is named in $1. So every single trace will have a different name. So this entire thing is considered one trace. It will have the same name throughout, in $1. And that in $1 is going to be literally just this line. When we connect our next line, we're going to see the name change. Click cancel. Connect T3 of the push button to VCC. T3 will connect to VCC. If I want to, I can press escape and I can literally move VCC over just to make it a little bit nicer. And I can move these up a little bit just to give this room. I can even rearrange and put our switch 1 symbol down here. C. So I try to keep it organized as I go so I don't have such a mess to clean up later. Every time you press the push button, it will supply VCC to the entire circuit through this VCC. Next, we need to connect with a net C1, CC1 with a 5.1K to ground, and also CC2 with a 5K to ground. So we're going to connect the resistors like this. VCC to LED1, LED1 to R3, R3 to LED2, LED2 to the next 100 ohm resistor. We'll scroll out, scroll in, and connect that to ground. There's our first one. And we're going to take our VCC connected to pin 8. We're going to take our VCC connected to R1, and then we're going to connect it to R2. We're going to connect over here. So we're going to connect the bottom of R2 to pin 6, like this. Pin 7 needs to connect between R1 and R2. Just like that. Notice that a dot is formed showing that is connected to that wire at that point. And connect pin 4 to VCC. That ties it high. Usually you'll see the name of the pin will usually have a line over it, or it will have a circle on the pin that indicates that it is an active low. So for the reset of this chip to happen, you have to put a 0 volts on here. And we are never going to reset this chip, so we're just going to tie it high, and that will take care of that. Connect pin 1 of the 555 timer to C2 pin 1. Connect pin 2 of C2 to pin 5 of the 555 timer. So that goes back to pin 5. Connect C1 cathode to ground. C1 cathode goes to ground. You can see where too many wires would get very hard to follow. Lines that cross can be confusing. Place a small stub of wire on pin 2 of the 555 timer. So we're just literally going to put a tiny stub right there. Hit escape. Now we're going to select label in the connect field. Connect. Label. And this brings up, we move this over here, and we're going to choose FREX on. We're going to rotate it 180 degrees, and we're going to click on the stub wire twice, and we're going to rename this label to trigger. So do a right click, name, and we'll call this, we'll just say trig, and we will place label. Hit escape. So instead of having this wire cross these other wires, we're just going to tag it right here, and then we're going to take the same label and connect it where else it needs to go. We're going to place another stub on the bottom of R2 like this. So go back to net. Click here, hit escape, that puts a stub on there. And we're going to once again put another label. This time this looks like the same. Double click twice, hit escape, right click, name, and we call that trig 2. or also I should say. Now when we name it that, it says connect the name of this stub to the trig line, which that's what this line has basically been renamed to. I'm going to click yes. And these, if you notice, if I do a right click properties on there, it's called trig. And the same exact line, I go to properties, it's also called trig. They are the same wire. So the software knows that these should be connected. Okay, this signal also needs to go to C1 here. So we're going to put a little stub here. I'll make it come out this way. Hit escape. I'm going to put another label. Everything should be good. I'm going to click here twice. Hit escape. Rename. And that's called trig2. And it's going to ask to merge those two connectors together. And so this is where all of that signal here needs to go. We also need to ground our pin 1 over here. I'm going to move ground over here. I'll just move it next to the other ground. And we'll place a net here. And we'll go from ground right here to pin 1. It says merge the segments. Yes. We definitely want to do that. And let's take a look at our circuit. Okay, right here, I seem to have connected these. This needs to go to T3. So I'm going to select this wire, delete it, this wire and delete it, move this wire down and connect it here. Okay, that should be correct. I think I am going to delete this line, and I'm going to copy our trigger and place it right here. Then I can take our output. I can move this in a little bit. Oh, I forgot to hit escape. I can move this in, move this wire in. And then our output is going to need a net, and it's going to go from here down, back up, and right in between our two LEDs. Okay, so looking at our 555 timer, we have the VCC, we have our threshold connected. Okay, what we're going to do now is we're going to add a couple 1-pin headers so we can easily connect our test equipment to it. So if we need to show any particular signals during our final presentations, you can easily connect the equipment to it quickly. And let's scroll back over to Place Components. And we're going to search for headers. And here are some of our pin headers. This is a 2x9. We're looking for just a 1x1. You see 1x2 is a 2-pin header. There's a 3D model of it. We're looking for a 1x1. Here we go, 1x1. And I'm going to place that right around here. And I'm going to place another one right here. And what I'm going to do is, since I want to see the output of this chip, I'm just going to put a new net. I'm going to connect this to our output. And for our oscilloscope, to measure this, we need a ground. So let's make an easy ground pin that we can connect to. And you know what? I'm going to rotate this chip twice, hit escape, and then I'll connect this part, and we'll just come up here and grab onto this ground right here. Now we have little pin headers that can act as test points. And I see this did not get connected properly. Okay, so we got V-bus going to T2. You press the button, it comes out, or this is normally open. When you press the button, VCC will be fed to all of these lines. And it looks like we have a finished schematic now. So what I'm going to do is I'm going to save this. And it says version description, user saved. And just notice, after it's saved, up here, it says Blink LEDs version 2 now, and it also updated in the title on the schematic sheet. Other useful things you can get from here, you can get a bill of materials, or a BOM, as it's fondly called. You can select your document and output and find your bill of materials. Okay, so it tells you every part, every value, every device you've selected, description, what package it is. This is something very useful. Another thing that you might want to do is on your output, you can print your schematic page. And with that said, we are done building our schematic, and we'll move on to a PCB.